Okay, in this video we're going to be working through 4.4 example 1. To solve those trigonometric equations, you're going to treat the trig ratio itself, like sine theta or cos theta or tan theta, as the variable, and then once you've isolated the trig ratio, you're going to use that inverse trig and then further isolate your theta or your x, depending on what the question asks. So the first thing we do in A is we are going to want to move all of our constants to one side, and any term that has that variable, even if it's locked inside the trig ratio, to the other. Personally, I like to keep my trig ratio positive, so I am going to subtract 3 sine theta from both sides. And then in the same step here, I'm going to subtract 2 from both sides. Now, what that gives me is that 2 sine theta, these cancel, is equal to 1 minus 2 is negative 1. Oops, and then the 3 sine theta is gone as well. That's not isolated yet. We do have to divide both sides by 2. And I get then that sine theta is equal to negative 1/2. Now, this is always that useful conversation talking about visualizing what we're actually doing here. If we picture the unit circle, which is x squared plus y squared is equal to 1, that gives us that nice circle centered at the origin. Really what this is saying is what angles on the unit circle have a y coordinate of negative 1/2. And if we draw that as another line, and I'll just do that in red, what that looks like is this. And the advantage of doing that is we see that there are 2 solutions. There's one in quadrant 3 and one in quadrant 4. Now that's a very kind of, I think, a good visual aid to talk about why there are 2 answers in one positive rotation. And then after we get those positive rotation answers, we can look at coterminal angles with a sequence and find all the solutions. So to go from here, we're going to exploit the fact that if sine theta is equal to negative 1/2, then the sine of our reference angle is the absolute value of that, which is positive 1/2. Now that does mean that theta reference is the inverse sine of 1/2. Certainly if you have your calculator, degree mode will tell you it's 30 degrees, but looking back up at the restriction, theta has to be in between 0 and 2 pi, which tells us this question needs to be done in radian mode. So exploiting some of that knowledge in the unit circle is going to let me know that theta reference will be pi over 6, and I was about to write degrees there again. Now that is radians, so it's going to match with our question. I always encourage students to diagram this, and with a very algebraic method, it's still an advantage to draw out cast, because if the sine of our angle is negative 1/2, then it has to be in quadrant 3 and quadrant 4. While that quadrant 3 answer, my reference angle is pi over 6, which means my rotational angle, theta itself, is going to be pi plus pi over 6, which means that angle is 7 pi over 6. Now in quadrant 4, I'll draw that again. The reference angle is still pi over 6, but because we're in quadrant 4, we have gone pi over 6 less than a full rotation, which is to say that that angle is 11 pi over 6. Now, in terms of a nice consistent technique, I think this is what we should do for all of these questions, and then take a look at the restriction. This particular question has the restriction that theta must be between 0 and 2 pi. And if I add or subtract 2 pi to either of these answers, we are going to be out of those restrictions. So the only 2 solutions that satisfy the restrictions given are 7 pi over 6 and 11 pi over 6. And I would certainly recommend that you put a little kind of summary at the bottom of what your answers are, especially as we start to get into general solutions and kind of uglier and uglier restrictions. Okay, we're going to do B in this same video. So I'll just give a little pause in case you want to take a look at whatever you've looked at. All right, in B, it gets a little trickier because we have one of those reciprocal trig identities showing up, or reciprocal trig ratio, same thing. And in this case, they use x for the variable, and that's fine. A variable is really any letter you want it to be. Typically, I like to use theta just because then we can talk about x coordinates and y coordinates. But we'll do this in a very, very systematic and algebraic way. So much like A, we are going to isolate the trig ratio. So that is going to be that 3 cosecant x, I'll show that, sorry. I'm going to add 6 on both sides. I get that 3 cosecant x is equal to 6. When I divide by 3 then, I get that cosecant x is equal to 2. But typically, students don't memorize the info for cosecant on the unit circle. So we're going to change that into its primary trig ratio, which is to say 1 over the sine of x is equal to 2. And if 1 over sine x is equal to 2, and I'll write 2 as a fraction by putting it over 1, what I can do is raise both sides to the power of negative 1, effectively taking the reciprocal of both sides. And what that gives me is a much cleaner formula to work with, which is that sine of the angle x is equal to 1/2. Now that should look a little familiar because we just kind of finished solving that other question that had this. The major difference though is, well, this is in degree mode. The other question was in radians. But the big difference is that when we look at cast, because the sine of our angle is a positive value, that angle cannot be in quadrant 3 and quadrant 4 because sine is negative in quadrant 3 and quadrant 4. So much like the other question, we are going to say that the sine of x reference is equal to 1/2, which means the reference angle will be the inverse sine of 1/2. And then very similar to last question, I don't want to belabor this too much, but we are in degree mode. So instead of pi over 6, I'm going to use its degree counterpart, which is 30 degrees. Now, most trig questions have multiple answers. And writing out cast helps us to identify where we would expect those answers to happen. And for this particular question, we have one solution in quadrant 2, where this is 30 degrees and that's x. My other solution is in quadrant 1, where this is 30 degrees and that little arc in there is x. Now, this is where it gets really nice and easy. Quadrant 1, the reference angle, or rather the rotation angle, is the reference angle. So this yields the answer that x is 30 degrees. In quadrant 2, we have to do a little bit of algebra. I always like picturing this with students that what we've done here is this x arc that I'm drawing a little bit thicker there is 180 degrees less 30. And certainly that language gets a little bit tricky, but the concept here is that x is 180 degrees minus our reference angle. And take another look at the chapter 4 instruction if you're struggling with that rotation versus reference connection. So the x angle in quadrant 2 then is 150 degrees. Please remember that both of these answers, the x equals 150 and x equals 30, you can check by taking the sine of those angles, and it needs to be equal to 1/2. And again, a nice little summary, never a bad idea. I would finish this question by saying that x can be 30 degrees or 150 degrees. I didn't really talk about the restrictions here, so I'm just going to write them again, that x had to be less than 360 degrees, greater than or equal to 0 degrees. We'll show that in interval notation with the square bracket on 0 degrees and the round bracket on 360 degrees. If I do add 360 or subtract 360 for that matter to either of these numbers, I will be well outside of that restriction. Therefore, those are the only two answers. Okay, that's example 1. Make sure you take a look at the upcoming videos as well.